Hi, my name is Connor McHale from Advanced Materials Technology, and today we're going to talk about extra column volume. Extra column volume is the volume in an HPLC system external to the column that contributes to the total peak volume. Most new HPLC chromatographic systems have been optimized and therefore are able to use high-efficiency SPP and fused core columns like Halo, but many older chromatographs are still in active use. Older chromatographs were used with longer columns packed with larger particle phases, where extra column volume in the injector and connecting tubing lines had less effect on resolution and peak width. Now, when switching to shorter, high-efficiency SPP columns, this extra column volume needs to be reduced to avoid peak broadening that can reduce the resolution and reduce the accuracy of quantitative results. Now let's have a brief overview of an HPLC system. So this is a typical HPLC system. It consists of a degasser, a pump, in this case we have two, an auto sampler where your injection is going to be placed, a column oven, which is where the column goes in, and a detector. Let's take a closer look inside. Extra column volume typically comes from the sample injector, including the volume of the sample injected, the tubing connecting the sample injector to the column, the tubing connecting the column to the detector flow cell, plus any volume added by heat exchangers, fittings, connectors, and inline filters. Extra column volume should be minimized in order to maximize the performance of the column by obtaining the best separations that the column is capable of. In general, you want to keep the extra column volume to less than 1/2 of the total peak volume to get 90% of the maximum resolution from a column. Let's take a closer look. First, we need to calculate the peak volume of a given peak. In order to do this, we multiply the flow rate, in this case 1.5 mils a minute, by the peak width, 0.04 minutes. This gives us a total peak volume of 0.06 milliliters, or 60 microliters. The total extra column volume in this example is 13.98 microliters, well below half of the total peak volume. There are several ways to minimize extra column volume. Number 1, your injection volume. You want to make sure that you keep your injection volume to a minimum. Number 2, your sample solvent composition. Keep your sample solvent strength equal to or less than the initial mobile phase if possible. If 100% organic must be used as your sample solvent, use minimum injection volume if possible. Number 3, your pre-column tubing volume. You want to make sure you use minimum lengths of ID tubing. Note that using multiple tubing IDs in the sample flow path can cause additional dispersion. For gradient separations, one can usually ignore the pre-column contribution to the extra column volume, except of course that this volume does contribute to the gradient delay volume. Number 4, your heat exchanger volume. Some instruments have column compartments with different heat exchanger volume options. This helps with thermal mismatch between the mobile phase and the column when elevated temperatures are used. You want to make sure you use the smallest volume consistent with flow rates, especially for 2.1 millimeter ID columns. Number 5, your post-column tubing volume. Use minimum lengths of ID tubing. Different tubing IDs in the sample flow path can produce additional dispersion. For 20 to 50 millimeter 2.1 millimeter ID columns, 75 or 100 micron ID tubing may provide better results at the expense of higher back pressure. Number 6, your detector flow cell volume. Use flow cell volumes 1 to 5 microliters for most 2.1 and 3 millimeter ID columns. Larger cell volumes can often be used for 4.6 millimeter ID columns in longer lengths. So let's take a look at a chromatographic example. In the figure, the performance of a 150 millimeter 2 micron halo column is compared using an isocratic separation with an HPLC in its standard configuration and a UHPLC system. In this example, the extra column volume from the standard HPLC configuration is 64 microliters and 16 microliters with the UHPLC system. With the HPLC in its standard configuration, the ultra-fast halo column provides slightly longer analysis time and low plates due to the peak broadening. In addition, the resolution is less than one would predict on the halo column. After moving to a UHPLC with lower extra column volume, the halo column delivers a high-speed separation with increased efficiency and baseline resolution. If you don't have a UHPLC, do not worry. There are several things you can do to get the high performance from your system. We recommend taking consecutive steps and modifying conventional LC equipment for use with high-efficiency SPP columns such as Halo, beginning with the easiest and cheapest modifications to make, and progress to more difficult and more expensive modifications as needed. Once you have achieved acceptable results, you may wish to forego any further equipment modifications. So these are a lot of changes to make, and you might be wondering what's the quickest way to reduce your extra column volume. Number 1. Decrease your detector response time and increase the data collection rate. A good place to begin is to set the detector response time less than 0.1 seconds and the data collection rate greater than 20 Hz. For example, in this chromatographic overlay, you can clearly see that as you increase your data collection rate, your plate efficiency also increases from 11,000 to over 38,000. Number 2. Reduce sample injection volume to a minimum amount necessary to achieve acceptable peak response. Number 3. You want to make sure that you keep your sample solvent weaker than the mobile phase. If this is not possible, it will place more restrictions on the volume of the sample that you can inject. If you are running gradient conditions, you will likely be able to inject considerable more sample volume than you would under isocratic conditions. However, it is still important to keep the sample solvent weaker than the initial strength of the mobile phase. Number 4. Replace the capillary connector tubing with smaller volume tubing of shorter lengths. And finally, number 5. Replace the detector flow cell with a smaller volume flow cell. I hope this video will be able to help you reduce your extra column volume on your HPLC system. If you have any additional questions, please visit our website at fused-core.com. Thank you.